Alright, welcome back. Now we're going to talk about logical operators, and logical operators are very important. They simply play with the truth values, whether something is true or false, and you combine these true or false values and you get interesting results. And why do we use this? Because the real life is more complex. You're not just saying, well, if something is true, then do that. You're using combination of these things. Combination of things in a way like if A condition is true and B condition is true and C condition is true, well, all of these things have to be true in order to do something. Or, well, even if one of them could do, I'm fine with that. Well, we do that using these logical operators, and there are three main logical operators: AND operator, OR operator, and NOT operator. So let's get right into it. First, we're going to discuss AND operator. As you can see, these truth values in this truth table, this is called a truth table. It just arranges the truth values. So if we have two variables or two booleans, two variables which can have any values, right? First truth value is the first variable and second truth value is the second one. So let's say if first variable had a true value and the second one had a true value, only then we have it true. That's the AND operator. AND operator requires all the values to be true. And for example, no matter what happens, all the things have to be true. If it is even a single one that is false, then that's wrong. That's not going to work. That has to throw false. So for example, if one of them is true and the other one is false, you just throw false. Well, the output is going to be false. If one of them is false and one of them is true, you just say, well, that's wrong, that's not true. And false, of course, they combine together to be false. Just think of it in real language as well. Like, okay, today is Sunday and today is 12 and today is this and today is this, and all these things have to be true in order for the real statement to be true. Now let's talk about the OR statement. The OR statement is pretty simple as well. As you can say, OR means it can be true. You have to complete this assignment, or you can do this, or you can do both. So this is an OR with a both, which means that even if one statement is true out of 1,000, you are okay. You can have a true statement as a result. For example, first statement is true, the second is true, true. The only scenario where it will be false if all of them are false. So you say something like, if someone committed a crime where they stole or they did something else or whatever, but if they did any of them, that's false, and you don't send them to the jail or anything like that. That's a possible way of looking at it. There are many ways of looking at it. In real world, you can just look around and just convert everything into these truth values. I mean, try and do that. That's a very good exercise. And now we're gonna discuss the NOT operator, which is pretty simple. As it says, NOT, it converts everything to the opposite of it. So if something is true, you apply the NOT operator, it converts everything to the opposite, to the not of that thing. Something is true is false. If something is false, it makes it true. Think of it like functions. NOT operator works on one value. OR operator works on two values. Even if it does on three values, it's always actually working between two values. That's what it is doing. So make sure that you see that happening. And we will discuss these complex scenarios just now. So let's do this in Python and see how it works out for us. Now let's use logical operators in Python. As you've seen before, that they let us combine and build logic. Now let us try some combination of the truth values as we tried in the slides. In Python, it's very simple. For example, if I want to use AND, I just type AND. It's pretty simple. And if I run this program, Python logical operators.py, and it should get true, because true and true is true, but everything else will be false. As you will see, if I say, well, true and false, well, that should be false, false and true, that should be false, and false and false should be false as well. Remember, that's false with a capital F. As you can see, they're all false. Now let's talk about the OR operator. And the OR operator is pretty simple as well. You don't have to use any fancy letter or character here. You just have to type in OR. For example, if I say print true or true, just use this true here, right here, and that will work just fine. For example, if I run this program, it'll give me true. Now remember that there is only one scenario where it is false, which is when both of them are false. Don't get confused if you think you don't understand OR and. It's just like real language, OR and AND. Just try to logic in real language and you'll get to the same conclusion that the truth values in a truth table for OR and AND are. Now let's discuss the NOT operator. And NOT operator is just, as discussed in the slide, it's very simple. It's just converting everything to the opposite of it. For example, if let's say I use true or false or false. Now make sure that all of this is in a bracket, and it goes from, it reads this and make sure that it's in a bracket, so that this is, whatever is in a bracket will run first. Just remember that. That's like the most important thing in logic building, and when you're writing these statements, especially these statements, make sure that this is in a bracket. And when you write not here, it converts that to the opposite of it. So if I run this program, I mean, you know what's going to be the outcome. True or whatever, doesn't care. It's going to be true. You convert that, it should be false. As you can see right here, it's false. Now true converts everything into the opposite. And that's all. That's the only reason we use not. And of course, there are many ways to arrange the similar logical statement. Now let's do something exciting. Let's convert a number into, let's see if that number is an odd number or an even number. And that program is very simple, but let's have a trick. If that number is even and greater than 200, then we want to do something. So let's convert this into an integer first. Remember, from typecasting, it has to be an integer in a string for it to be converted to integer, otherwise it'll throw an error. How to handle that? Well, we'll discuss that soon enough. Now, this number, you take its modulus with 2 is equal to 0, you know. The numbers divisible by 2 are the even numbers. And we can do something like AND here. And now this is where you have the real world scenario. You can say, well, the number is greater than 200. You can do grading of students like this. It's a very famous, well, many people use that example. So number is greater than 2, greater than 200, and even. And in else, you can say, well, number is less than 200, or it could be less than 200, or may not be, because these both have to be true. It could be that this is false and this is true, or this is true and this is false for it to be wrong, or both of them to be wrong, right? So, or the number is odd or both. And if we actually run this, let's write 43, the number is less than 200, of course, and odd, and actually it's both of them. Let's say I write 761, same answer. If I write 760, the answer will be different. It's greater than 200 and even. Now you can use the similar logic to calculate grades. If it is, I mean, between 60 to 70, grade them D, you know, 90 above A, 80 above B, stuff like that. So this is how you use the logical operators. Use them wisely, and I'll see you in the next lecture.